Let's look at monomial, binomial, trinomial, polynomial. So what is a polynomial? Think of polynomials as adding and subtracting power functions. The case where n is positive integer only, so n, we're going to have to limit it to a positive integer only. And the basic form is this. So I have y, or f of x if you like. And then you have this number. It's a real number, or even it could be imaginary, a complex number. And you have your variable here, x, and it's raised to the some power, nth power. And then I'm going to write these in order. All this means is that this could be another number in front of this other, well, this variable, but raised to the n-th one, and so on. So you have, like, for example, x cubed, x squared, and so on. And some of these other ones can be 0, but this, for the first one, the highest power is going to be known as the leading term. And we'll see in a second. But if I were to write from the highest to the lowest without skipping anything, then eventually you get to what is a quadratic equation, then a linear equation, and finally a constant. So x to the 0th power just means 1, and you have this constant. So this is the basic look of a polynomial. If the polynomial has only one term, it's called a monomial. If the polynomial has two terms, it is called a binomial. If the polynomial has three terms, it is called a trinomial. Other than that, you just call it a polynomial. So is f of x equals 3x squared minus 5 a polynomial? So what I'm looking at is, first of all, is this a positive integer? And the answer is yes. And these are real numbers. So the answer is yeah. And of course, the variable is the base. So yes, this is a polynomial. And to be more precise, is a binomial because it has two terms. What about this? This is a polynomial. You got x cubed minus 4x squared plus 2x to the negative 2 power. And all of a sudden, we have a problem right here. This is not a positive integer. So this is not a polynomial. Okay. How about this one? Is this one a polynomial? And the answer is yes. And I go, well, how could this be? There's no x variable. Well, this is going to be this last case right here. So we have x to the 0th power, we'll just call that 1, and there's a constant. So this really could be looked at as 4x to the 0th power. So it is a polynomial, and to be precise, it is a monomial. Which means single term. Okay. So this one's not a polynomial, so we won't call it. It has three terms, but it's not a polynomial. So now we get to this next part here, which is degree of a polynomial. The highest power exponent, really, in a polynomial determines the degree. If a polynomial has more than one variable, then the sum with the highest power is the degree of the polynomial. Okay, so the highest power, it determines is the degree of the polynomial. And what does that do? So the degree of a polynomial determines its size. The number of terms does not determine the size. The number of highest power term is called a leading coefficient. So again, when we look at something like this, this is going to be a second degree polynomial. Because the power here is a 2 and it is a binomial. Because it has 2 terms. Okay, so there's a couple of examples here. What is the degree of the polynomial 5x plus 4x cubed plus 7x to the fifth? Again, so now I look at this one. This one has the highest power. So this is going to be a 5th degree. And this has 3 terms, so I must call it a trinomial. Now, what is the leading coefficient? Leading coefficient is the number in front of that variable, which is 7. 7 is the leading coefficient. What is the degree of the polynomial in this case? And what's the leading coefficient? So what's the difference between this form and this form? Well, here it's been multiplied out. So right now this is in factored form. So does that mean that in order to determine degree, I need to expand or FOIL? The answer is no, because if you recall, if you were have a, let's say, quadratic like this, and you had to FOIL this, remember the highest power, the leading term comes from first times first, this position. So when I start multiplying out, I get 3x squared. So immediately I would understand that this is the leading coefficient, sorry, the leading term, highest power term. You know, put things in order, and so this would be second degree. Right? With a leading term of 3, or a leading coefficient of 3. So how does that help us? Because if I were to expand this, same idea would hold. The leading term only comes from this first part. So what this whole function turns into, if I were to multiply it out, the leading term will come from 3 times this value raised to the third power, when I multiply this 3 times by itself, times, eventually I would have to multiply them. This one gets multiplied eventually 5 times, so x to the 5th. So again, I'm only interested in the leading term. The size of this thing would be quite large. And finally, at some point, I would have to multiply this, the highest power, times this to get even higher. So looking at those positions with the variable until, and then just multiply first times first times first times this constant, I would have this being 3 times, again, here's 8x cubed, x to the 5th times x is x to the 6th. And again, when we multiply this, we actually adding the exponents. So we got x to the 9th, 3 times 8 is 24x9. So this is a ninth degree polynomial. with leading coefficient of 24. What is the degree of this polynomial? Again, this is a constant. The answer is going to be 0-degree polynomial. So a constant is going to be a 0-degree polynomial. And again, why is this important? Because this will determine the size, and it will help us when we want to graph this, and it's going to help us in the next topic.